Hi everyone, in this lecture we are going to discuss one example problem related to equilibrium of two-dimensional rigid body system. Okay, so let's read the problem together. So find the components of the support reaction at the fixed support A on the cantilever beam. Okay, so this is the cantilever beam. Okay, it is not straight because it has this portion that is going up, right? And then this beam is fixed at point A. Okay, so basically in structural analysis, when we have a beam that is fixed at one end and then free at the other end, right? So this end is fixed and this end is free. We call that structure as a cantilever structure or cantilever beam. Okay, right? So I think it's always a good idea when you try to solve any static problems is trying to sketch the free body diagram first. Okay, so I redraw the beam right here. And we know that for a fixed support, there are three possible reaction forces. The first one is AY, and then AX, which is the reaction forces in the vertical and horizontal direction. Okay, and also MA. Okay, this reaction moment is actually occurring at point A, but I just draw it a little bit away from point A for clarity. Okay, and noted that how I draw the reaction forces in here, I put a little dash on the arrow to indicate that those are the unknowns, right? Those are the forces that we are going to calculate, right? Which in this case is the support reactions at A. Okay, then in here we apply 6 kilonewton force, and in here we apply 4 kilonewton force. Okay, this angle right here is 30 degree. This angle right here is also 30 degree. Okay, this distance is 1.5, this distance is 1.5, and then this length over here is 1.5 meter. Okay, so based on this, we have to find what is AY, AX, and MA. Okay, so since there are three unknowns in here, okay, and we know that at most we can write three equilibrium equations, which is sum of the forces in X, sum forces in the Y equal to 0, and then sum of the moment at any point equal to 0, right? Then we will be able to solve for the unknowns. Okay, so three equations, three unknowns, then it should be solvable. So the challenge in here is whether we can write the sum of the forces in the X, sum forces in the Y, and sum of the moment. Okay, and you can see that this is the reasons why we put this module after we discuss module 1, 2, 3, and 4, because in module 2 we have learned how to write sum forces in the X and sum forces in the Y, and in module 4 we have learned how to write sum of the moment. Okay, and then the matter in here is just to set it equal to 0, right? Okay, then let's start the analysis. Okay, I'm going to zoom out a little bit right here. Okay, right, then I think it's good to, I will redraw it a little bit in here, or let me just copy it. All right, okay, so before we solve the problems, it's always a good idea to decompose any force into x and y directions, and let's assume that this is the x-axis and this is the y-axis. Okay, and then in here this component of forces right there is 4 cosine 30 degree. Okay, and the component of the force right here is 4 sine 30 degree, right? Okay, because we know the angle right here is 30 degree. Okay, so I first decompose this 4 kilonewton force into its x and y components. Okay, and we can start to write some of the forces in the x direction right now, and in here we have ax. Okay, this force only have a y direction, so it doesn't have any contribution to some of the forces in the x direction. And then we have this 4 cosine 30, right, plus 4 cosine 30 degree equal to 0. Okay, so in here we obtain that ax is equal to negative 4 cosine 30 degree. So when we calculate this, we obtain negative 2 square root of 3 kilonewton, because the 4 in here is in kilonewton. Okay, then let's write sum of forces in the y direction and set it equal to 0 later. So we have ay, okay, it's going up, so it's positive. And then we have 6 kilonewton is going down, so it's negative, right? And then we have the y component of the 4 kilonewton force, right, and it's going down as well. It's negative 4 sine 30 degree kilonewton, and that's all, right, equal to 0. So in here I obtained that my ay is 6 plus 4 sine 30 degree is equal to 8 kilonewton. Okay, and the last equations that we can write is sum of the moment. Okay, and in here you can pick any point, but I would like to pick point A. Okay, is there any reasoning? No, but if I know that if I pick point A, I will not include ax and ay because they are passing through point A. Okay, so sum of moment at A, I have MA, right, and MA is counterclockwise. Okay, so it's positive, right? And then let's calculate the moment of this 6 kilonewton force about point A. We have 6 kilonewton, right, multiply with its perpendicular distance, right? This distance is the perpendicular distance, and that's 1.5 meter, right? And since the force is going down, okay, so it's going to cause a clockwise rotation about point A, right? So it's a clockwise rotations, it's a negative, right? So let's do the y component of the 4 kilonewton force. Here we have 4 kilonewton, right, times sine 30 degree, the y component of the 4 kilonewton force. Okay, multiply to the moment arm is the distance that I underline in yellow right here. Okay, because this is the line of action, right, and this is the perpendicular distance. Okay, so the distance is 1.5 plus 1.5 plus this distance is the length in here is 1.5 cosine this angle 30 degree, right? 1.5 cosine 30 degree. So let me write it down in here. Multiply with 3 plus 1.5 cosine 30 degree. Okay, and since the force is going down, the y component of the 4 kilonewton force is going down with respect to point A, it will cause a clockwise rotation as well, right? So it's going to have a negative sign, right? So the last force in here is the x component of the 4 kilonewton force. Okay, so we write it down here, 4 kilonewton cosine 30 degree. Okay, this is the x component of 4 kilonewton force. Okay, and to give a note in here, this is the y component of the 4 kilonewton force. Okay, so in here the moment arm is in here. If I can extend, first we extend the line of actions of the x component of the 4 kilonewton force with respect to point A. The perpendicular distance is this, right? And that distance is calculated by, is the same as this, right? So it's 1.5 sine 30 degree. Okay, so that distance is 1.5 sine 30 degree meter. Okay, and this everything is equal to 0. Okay, and if we see that in here with respect to point A, the x component of the 4 kilonewton force is going to the right, so it will cause a clockwise rotation as well. Okay, so it has a negative sign. Right, then we can calculate MA. We move this expression, this expression, this expression to the right hand side of the equations, right? So we have 6 times 1.5 plus 4 sine 30 degree times 3 plus 1.5 cosine 30 degree plus 4 cosine 30 degree times 1.5 sine 30 degree. Okay, perform these calculations, and if my calculations is correct, you will obtain 20.2 kilonewton meter. Okay, all right, so in the finalized step, okay, in the final step, usually I like to redraw everything one more time. So in my finalized step, I would like to redraw everything one more time. Okay, we have the 6 kilonewton force, then we have the 4 kilonewton force in here. Okay, then we have the reaction support. AY is 8 kilonewton. AX is negative, right? So since initially we assume it's going to the right and we obtain negative value, then it actually means that the real direction, the actual direction of AX is going to the left. Okay, so AX in here is 2 square root of 3 kilonewton. Okay, and MA is 20.2 kilonewton meter. Okay, so notice that all of these reaction forces are actually occurring at A. However, when I draw this MA, I draw it a little bit away from A just for a clarity reason. Okay, so to summarize, it's very important to have a correct and proper free body diagram with all of the forces are drawn, right? And all the geometrical properties like the length, the distance, the components are known. Okay, or at least you can calculate it afterwards. Okay, so with that, everything is just about whether we can write the sum of forces in the x, sum of forces in the y, and sum of the moment. Okay, once we are able to solve that, then the unknown should be able to be obtained. Okay, I think that's it for this lecture, and thank you for listening.